Let's now look at the second derivative test and walk through some examples. The second derivative test is used to find where a function has a local maximum or a local minimum. This may seem familiar to you. The first derivative test is also used to find where a function has a local maximum or a local minimum. These two tests give us the same result. So what's the difference? The second derivative test is easier to use when the critical numbers are close together. Because remember with the first derivative test, you have to pick a point in between each region and test if it's positive or negative. With the second derivative test, you don't have to do that. You just have to find the value of the function at a point where the second derivative is equal to 0. Let's go through all this. The second derivative test tells us that if f prime at c is equal to 0, let's look down here in our graph. Here's c, and we have a derivative equal to 0 because we have a horizontal tangent. Now we have an and f double prime is greater than 0. So it's greater than 0 at c and to the left and right of c. So it is concave up, and that means that we have a local min at x is equal to c. Same thing happens for concave down. If our derivative is equal to 0, that's this point right here, and our second derivative is less than 0, it's less than 0 at c, to the left and to the right, then our function is concave down, and we have a local max at x is equal to c. Let's now walk through some examples. In these examples, we are going to use the second derivative test to find the local maximum and minimum values of f of x. I've written down some steps that we can follow. The first step is to find the critical numbers, and then the second step is to find f double prime, and then check if f double prime is positive or negative at our critical numbers. And then step 3 is we just calculate the local max and mins. Let's see how this works. The first function that we're given is a polynomial, and its f of x is equal to x cubed minus 6x squared plus 5. Our first step is to find our critical numbers. So we're going to take the derivative. F prime of x is 3x squared minus 12x. We are going to set this equal to 0. We can factor out a 3x, and we're left with x minus 4. So this gives us that x is equal to 0 and x is equal to 4. Now, in step 2, we are going to find the second derivative. That second derivative is going to be based off of our first derivative. So we're going to differentiate that. So we're going to have a 6x minus 12. Now we don't set this equal to 0. Instead, we take our critical numbers, that's this number, and we substitute it in for x. So f double prime at 0 is minus 12, and that is less than 0. So that tells us that we are going to have a local max at x is equal to 0. Remember, it's just opposite. If it's less than 0, you have a max. If it's greater than 0, you have a min. Now let's find f double prime at 4. This is 6 times 4, so this is 24 minus 12. That is greater than 0. The value doesn't matter. We're just checking if it's positive or negative. If it's greater than 0, that tells us that we're going to have a local min at x is equal to 4. Now, in step 3, we actually have to find out what the minimum and maximum values are. So we need to go back up to our original function and plug in those x values. We have f at 0. That one's easy. That's just equal to 5. So that tells us that we have a local max equal to 5. And that, of course, is at x is equal to 0. Now let's plug in 4. This is going to be a little bit more work. F at 4 is 4 cubed minus 6 times 4 squared plus 5. Let's see. This is 4 cubed is 64 minus 6 times 16 plus 5. So let's see, 64 minus 96 plus 5, that is actually minus 27. So that tells us we have a local min equal to minus 27, and that occurs where x is equal to 4. Let's now look at our second example. This one has trigonometry in it. We're given the function f of x is equal to x plus 2 sine x, and we're told that our interval is from 0 to 2 pi. Let's start by taking the derivative. F prime at x is equal to 1 plus 2 cosine x. Now we need to set this equal to 0 and find our critical values. This gives us cosine x is minus 1/2. Let's see. Cosine is going to be negative in quadrants 2 and 3. In quadrant 1, when cosine is 1/2, x is pi over 3. So using reference angles in quadrant 2, x is pi minus pi over 3, which is 2 pi over 3. And then in quadrant 3, x is going to be pi plus pi over 3. So that is 4 pi over 3. And let's go ahead and let's highlight these because these are our critical values. In our second step, we are going to take the second derivative. So we have f double prime of x. I'm looking right up here to take the derivative. The derivative is going to be minus 2 sine x. Now what we have to do is we have to find the value of f double prime at those critical values. So we have to calculate f double prime of 2 pi over 3. This is minus 2 sine 2 pi over 3. 2 pi over 3 is in the second quadrant. Sine is positive in the second quadrant. So this is going to be less than 0. And this means that we are going to have a local max at 2 pi over 3. Now let's find f double prime at 4 pi over 3. This is equal to minus 2 sine 4 pi over 3. Sine is negative in the third quadrant, so we have a negative times a negative, so this is going to be a positive, so we'll mark it as greater than 0. And this tells us that we have a local min at x is equal to 4 pi over 3. Hang with me. What we have to do now is find the value of the local max and min. So we have to go back up to our original function and see what that function is equal to at 2 pi over 3 and 4 pi over 3. Let's first calculate f at 2 pi over 3. This is 2 pi over 3 plus 2 sine 2 pi over 3. This is 2 pi over 3 plus 2 sine of 2 pi over 3 is root 3 over 2. So we get 2 pi over 3 plus root 3. This is approximately 3.83 if you put it in your calculator. We can highlight this then as our local max. Let's go ahead and highlight all of this in green. There's our exact value, our approximate value, and it's a local max. Now let's do the same thing for f at 4 pi over 3. Looking back up to the top in pink, we have 4 pi over 3 plus 2 sine 4 pi over 3. This is 4 pi over 3 plus 2. Sine of 4 pi over 3 is negative because it's in the third quadrant. And we have a minus root 3 over 2. So this is 4 pi over 3 minus root 3. Putting that into your calculator, you get approximately 2.46. And this is a local min. And that's it.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.